Hello there, welcome to the Math Tutor channel. I'm here to explain about there's a question in front of you. It's a mechanics question. As I always tell you, mechanics is math and physics, so please follow, pay attention, focus. Any questions you can add to the comments. And this is a past paper question. Share, subscribe and like. And when you watch, please tell your friends so that you all get a good grade at the end. Alright. Okay, so this is the question. Three complanar forces of magnitude 150 and 50 act at point A as shown, and the value of cos alpha is 4/5. Okay. Find the magnitude of the resultant of the three forces and state its direction. Okay, so we all know that resultant force is equal to, I always do this, the driving force minus the driven force. Okay, when you look at this diagram, you realize that the driving force is 100, okay, and the driven force is this side on the right. Okay, so to get resultant, we shall get the driving minus, we do what we call resolving. So I'll teach you how to resolve. So in this triangle here, 50 newtons has a horizontal component. So if we had to find the horizontal component, this horizontal component right here, it will be 50 cos alpha. Okay, still when you are resolving this other 50 that is pointing downwards, it will still be the same 50 cos alpha. So here we have 2 times 50 cos alpha. This is the horizontal component that will be active at point A. So since they have told us the value of cos alpha, so R will be 100 minus 2 times 50 times 4/5. So here when you reduce or simplify that, you get 100 minus, so this is 10 times 4 is 40 times 2, 80. Okay, okay, there's one important factor that we left out. It's really important when you're dealing with force. Okay, anyway, let's first continue. Yeah, because we know that, by the way, we know that force is equal to ma, so resultant force is mass times acceleration. So this driving force minus driven force, okay, is the resultant force. Okay, but we have to equate it to mass times acceleration. Remember, in this question, let's see, is there anything to do with mass and acceleration? Let's read it and see. No, I don't think so. Let me see. Three component. Oh, no. There is nothing. Oh my god, there is nothing. What am I doing? Sorry about that. Okay, we're on the right track. So for resultant force is driving force minus driven. So as we have followed the steps, I hope you're following. The steps are correct and clear. So our resultant force will end up being 20 newtons. But how do you tell the direction of flow? How do we tell the direction of flow? So the direction of flow is always the direction of the stronger force. So the stronger force is 100. So we say to the left. Okay, so that is the answer. That is the answer to this question. Yeah, there is no part up. I thought there was a part up that gives us some details of their mass and everything, but there's no part up. Okay, so this is a solution to this question. And let's continue to another part, number 2. Number 2 says the car of mass 1800 kilograms is towing a trailer of mass 400 along a straight horizontal road. The car and the trailer connected, so let's draw a sketch. We have a car, okay, and we have a trailer, and they are connected by a light rigid bar. So this is a bar, okay, and the car is towing, so meaning that here we shall have what we call tension. Okay, we shall have tension. Okay, the car has a mass of 400, so this is the weight, and I beg your pardon, the car has a mass of 1800, and the trailer has a mass of 400. So the G means acceleration due to gravity, so it is weight, and the car is accelerating, so it is moving that side at 1.5 meters per second squared. Okay, and the resistive force on the car, so if the car is moving to the left, so the resisting force is to the right, 250 newtons, it is to the right, and the trailer has another resistive force here, which is 100 newtons. Okay, so this is what we have, and they're asking us to calculate the tension in the bar, so this is the bar. So the tension in the bar, so you realize that T is fighting against, it is driving 100, so like from force is equal to mass times acceleration, so resultant for, so T, the resultant of T and 100, okay, is equal to the mass of what? The mass of the trailer, because T is between the trailer is between T and 100, so 400, and the acceleration, the trailer is moving at this acceleration, the same acceleration as the car, 1.5. okay, so making T the subject, it is 400 times 1.5 all over, no, not all over, sorry, 100 crosses over, so it is plus 100. Okay, so checking on the calculator, 400 times 1.5 plus 100 gives us a very, very beautiful answer of 700 newtons. Okay, so this one has been solved, part A. I hope you understand. Let's go to part B. Part B is asking for the power in the engine at that speed. Okay, so we know that power is equal to force times velocity. Okay, so we need to know the force. Okay, because we need the power of the engine, we need to know the force exerted by the engine. So in our illustration, if we add an F there to represent the force on the engine, you realize that this force is driving this, is fighting against this resistive force and this resistive force. Okay, so there it is opposing actually. So what we do, we shall say F is equal to, no, I beg your pardon, not equal to, F minus, okay, we are getting the resultant between this and these two, so F minus the two forces, 250 plus 100. Okay, now this will give us the resultant is equal to MA, since F is equal to MA, don't forget that, is equal to MA. So the mass of the combination of the car and the trailer will give us 1800 plus 400. This is the mass, and the acceleration is 1.5. Okay, I hope you are following, and I hope you are understanding. So 250 plus 100 will give us 300, so F minus 350, okay, is equal to 1800 plus 400, it will give us 2200, but times 1.5, so F alone will be So remember, this is a 0.5, not 15. Okay, so 1.5. On the right hand side we shall get 3300, but we shall add on 350 because the 350 is negative on the other side, and then F will be 3650. Okay, these are newtons. I hope you're still following. Now we come to getting the power. So power will be 3650 newtons times the velocity, which is 20, and that gives us the power, which is 73,000 watts. Okay, yeah, or someone can say P is 73 kilowatts. Okay, yes, so this is the answer to this part. I hope you've enjoyed the mechanics part. It is both physics and math. See you in our next video. Subscribe, like, and follow. Share. It is always lonely at the top, so make sure you get a good grade and help your friends get a good grade as well. See you. Bye bye.